Here we have section 6.2, which deals with parallelograms. So there's our main ideas, vocab. So parallelogram is any quadrilateral with both pairs of opposite sides parallel. So there are some other things that are true, but that's what's required for it to be a parallelogram. So here we have the other things that are true. So the first one there, which is 6.3, is the opposite sides of a parallelogram are congruent. 6.4, opposite angles are congruent, so that means like A and C or D and B. Consecutive angles are supplementary, so A and B, B and C, C and D, D and A, they have to add to 180. And then the last one, if a parallelogram has one right angle, it has four right angles. So down here, angle K is right, which means all of them are right. Now, that happens because if adjacent angles are supplementary, if K is 90, G has to be 90, which means H has to be 90, which means J has to be 90 because they have to add up to 180. So one of them's 90, the other one's 90. Okay, so here we have example one. Quadrilateral LMNP is parallelogram, designed to be part of a logo. Find angle PLM, angle LMN, and the value of D. So to start, I'm actually going to combine those two. That is 108 degrees total. Now, if that's 108, and I'm going to do a whole bunch of math without worrying about the questions. If N is 108, I actually know L is also 108 because opposite angles are congruent. I can figure out M and P because adjacent angles or consecutive have to add to 180, which means this guy is 72. He's 108 plus 72 is 180, as is that guy. Now I'll actually answer the questions I want you to do. So measure angle PLM. So PLM is that one right there. So that's 108 degrees. LMN. That one is 72 degrees. And the last one, to find D, I have to use the sides. Now, in a parallelogram, opposite sides are equal. So 2D is equal to 22. So divide both sides by 2. D is 11. All right, next page here. So this deals with diagonals. So if you have the diagonals in a parallelogram, which are US and RT in this case, they bisect each other. So here you have point Q. So Q is the midpoint of both US and of RT. So example 2 here, where the coordinates of the intersection of the diagonals of a parallelogram ABCD with given vertices. So there's actually a trick for this. It requires you to remember the midpoint formula, which is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, since these are listed in order, every other one are opposite. So A and C are in opposite corners. Same thing for B and D. If you look up here, if I could draw the diagonal through opposite corners, the midpoint is where they cross. So I just need to find the midpoint. So I'll do A and C. So x1 plus x2 over 2, comma, y1 plus y2 over 2. So that's going to be 6 over 2. So that's 3. 5 over 2 is 2.5. If I actually do the same thing with B and D, I'll get the same answer. Be 6 again. 6 plus 0 is 6 over 2. For the y's, 6 plus negative 1 is going to be 5 again, so I'll get the same value. All right, and the last slide here just states that if you draw any given diagonal in a parallelogram, it makes two congruent triangles. So in this case, you have ACD is congruent to CAB. Now remember that when you name triangles congruent, you have to keep the corners consistent. So this triangle has to rotate, which means point C ends up on top of point A, which is why here A and C are the same. And then D ends up on B, so on and so forth. So there's the end of the section.